All right, I guess there's a check-in going around, but as we're getting ready here, my name is Mark Roberts. I'm with the Age Verification Providers Association, and we have Paco from Yoti and Philip from Lucidity here. We're gonna go through kind of a basic outline of what a public key directory and infrastructure is, and then do a demo between the two companies to kind of give a working prototype as to what it looks like. So, okay, so first off, what is a PKI and how can it allow age assurance providers to have the concept of interoperability? It's basically, so PKI stands for Public Key Directory, Public Key Infrastructure, and it's a method which can be utilized to confirm the authenticity of a digital proof of age. Issuers that are approved can utilize private keys to sign data and then enable a proof of age app to actually generate the signed QR code, where any website or reader app or even a point of sale can access the corresponding public key, which will be able to help them identify the signature and confirm that the data is from one of the approved issuers. So in this infrastructure, basically we have certificate authority, and they help generate the certificates and establish a chain of trust whereby each certificate can be traced back to a root certificate authority and establish that there's in fact like authenticity with who has generated and provided the certificates. So this is basically achieved by setting up what's known as a public key directory, where each of the issuers provides their public keys into the directory, which then can be downloaded and used both online or offline even to actually facilitate the lookups of any of the information needed to receive and verify that an authentication came actually from one of the issuers that is in the system. The PKI, so basically what it does is it allows for an interoperable data minimized approach that can be used both online and in person, even offline. Like I said, it can support the use cases in various things such as e-commerce, dating, social media, gambling, and adult content. And it can support use cases both in person, such as like retail or gambling machines, or again, online as well. And it can produce different forms of age checks, including age tokens that are interoperable and come basically through different approved methods that are approved by the various vendors in the system. You can operate this on a global setting, not just local. And this is something that'll allow choices for consumers, essentially. In terms of the interoperability and in-person age check, what the first thing that's needed is the central hub, which is basically the PKD, which is operated by a trusting body that can, be determined like in accordance with what everyone feels comfortable with in terms of making it, not something that's owned by a non-neutral system. And the PKI is scalable to enable trust from the issuers, and it can be a light solution that's used in things like the EU consents phase 1 pilot. So again, on and offline interoperability is one of the goals and desires needed to do the age verification. So this is kind of one of the possibilities of getting us there. The phase 2 of EU consent is providing leadership and structure for age verification to adopt and include a device-based approach enabled by the PKI. From this point, I'm going to actually hand it over to Paco so he can take us through sort of the technical demo and how everything works.
Hi everyone, Paco Garcia. I'm the CTO of Yoti. I hope you all, fed and caffeinated. We're going to get a bit more the technical elements of this. So we just wanted to show you a real interoperability between two APA members, between Lucidity and Yoti. And before we jump into the demo, I'd like to touch on upfront on some of the technical details, because I'm sure you have some questions into, what's in the QR code? Is it privacy preserving? Is it anonymized? So this is just a normal flow. Basically, a user needs to check their age because they are accessing an age-restricted goods or service. This maybe is a bit more like a web-based type of thing, but I like to call that for your imagination, because this could be anything. It could be a terminal, it could be a self-checkout system, it could be anything that you need to verify age, either in a face-to-face scenario or online. But basically, the user needs to prove their age, and they're going to provide an age token. We'll get into the details of what's in there, because it doesn't have to be the actual age. It could be, an 18 plus, 21 plus, a particular age range, whatever is needed from the regulatory perspective to ensure that there's no harm done to minors. The way the token is secure, processed, and shared, there's one way to do this in browser. So you can have the age token stored in the browser and reuse in a particular time window, which is specified by the local jurisdiction. So some regulators may choose to use it, it's valid for 24 hours, while maybe this thing for that particular service, the risk is not that high, and that can be used for, 3 days, 7 days. All that can be configured to meet the local jurisdiction regulatory requirements, as you will see in a minute. But once the token is shared with the verification party, they can use all of this PKI system that we built, which is it's a very well-proven system. So I'm sure everyone around the table has used PKI today, because the moment that you go online, you make a payment, you're using PKI. So it's a very well-proven, tested technology. It's not something that we came up with just for age verification. It's been ongoing for 20, 30 years. It's used on all the mission-critical infrastructure around the world. But yeah, the idea is that any verifier who's been authorized by the app association or a wider association like EU consent or some of the international association, if you are part of this, you can verify credentials, because it's all part of the public key directory. So what's in the token, right? This is one of the key things that we had to look at the privacy by design approach. So we need to make sure that there's no identifier that can be used to correlate or to link a particular user to access a system. So there are some properties that have been very well thought in terms of what goes in there, so there's no risk of correlation or anything like that. So one important element is the timestamp, because in order to enforce this time window, according to the local jurisdiction, you need to make this available for, say, 24 hours or 1 day or whatever. So that's part of the credential. The liveness, it's important to do the biometric binding in a way, because otherwise anyone else can generate an age token and then sell that in a marketplace for a price. Maybe a minor can actually buy that token and use it. So that biometric binding or liveness process that can happen on device, it can happen on the browser. It's important to be part of the credential to ensure that there is that biometric binding happening. The age, or in this case, the age range or age requirement, to assert that in order to access that service, that particular jurisdiction age is being met. The method, which is basically establishes how the age check is done to meet a particular level of assurance. So again, this is a very flexible system to make sure that not only APA, but any other initiatives, as we'll see, can use this system to be able to comply with the local jurisdiction requirements. Finally, the signature. So obviously using the PKI system, the credential will be signed with the private key of the issuer, and the verifier will check with the public key that the credential is valid. I'm going to skip the demo because the slides, because we'll want to show you this in practice in a sec. This is a bit of more detail into what goes into the credential. It can be extended to also incorporate elements of geolocation if you want to make it more restricted to say this credential is only valid in these particular supermarkets, right? So that's kind of a way to mitigate the risk of someone generating credentials that can be used anywhere. So again, it's a quite flexible system. This is a bit of how the public key directory looks like. We wanted to make a really cost-effective solution. So rather than inventing everything from scratch, we're leveraging on GitHub, which is a publicly accessible system to actually implement the PKI. So this basically means that we've managed to reduce the cost to virtually zero because we don't have to implement the service, operate the service, secure the service. So we're going to have to deal with things like denial of service attacks and things like that. So I think this is a very smart way to implement this at scale, at a global scale, at a virtually zero cost. This is about what levers are available to the regulator to fine-tune in terms of defining the maximum time that the token can be considered valid, the different methods of age verification that are accepted for that particular regulator to ensure that level of assurance can be met, the type of age range to access a particular service or good, the threshold in case that you want to make sure it's over 18 or 21 or whatever. It doesn't have to be just 18 plus. It could be even 13 plus, right? If you want to access some chats or online or gaming platforms. The type of liveness checks, because not all of the liveness checks are created the same. There are different degrees of security. There are some ISO standards that establishes the strength of liveness checks in terms of level 1, level 2, and now we're seeing more effort into the injection attack detection system. So it's not only the presentation attack, but also how do you make sure that there is no a deep fake or generative AI video injected into the system. So all of that will be allowed, to be set by the regulator in terms of what's acceptable or not. And the type of authenticity checked that's performed. So obviously, this PKI system is not yet a new solution. It's just the basic, secure, and trust infrastructure that can be used by already existing wallets or frameworks like the upcoming EIDAS 2.0. Yuri wallet can be used this system as an extended attribute to do age verification in all of Europe, right? So this is an architecture system that fits in nicely into that wider framework of Europe. But it doesn't have to stop there. It can be an international approach, similar to, for example, the ICAO, which is the International Aviation for Civil Aviation. This is the organization that sets the standards for biometric passports. So if you've gone through border control and put your passport in place, they're using a PKI system. All of the countries in the world that are member of ICAO, which are 120 countries in the world, it works really well. Like people are flying around using this PKI system. So again, it's a very well-proven technology that we can reutilize for age verification. And again, I know I'm aware that there are different initiatives from different regulators at the member state level, which they're really keen to demonstrate the technology to ensure that this can be used by the consumers, and there are the necessary regulatory checks to make sure that the technology is certified, it's good, and it works. But the idea is that any of these initiative will need some sort of PKI system at the end of the day. Doesn't matter if it's a centralized system or decentralized system, if you use zero knowledge proofs or whatever, you're always going to need a root of trust. And this is what this PKI is implementing and enabling the interoperability among the stakeholders. So I'm gonna start with the demo. This is a bit of how it would look like as a final thing. So we've got the Lucidity wallet on the right and the Yoti wallet on the left. We're gonna demonstrate the proof of concept. So it's not gonna look as nice as this because it's something that we put together in less than half a day. But the concept is that Yoti will create a QR code with the age credential, and then Lucidity or any other APA member or member that uses the technology can use to verify. So you are enabling universal acceptance. Any company involved in this can issue credentials and can also verify credentials using the technology. So what I'm gonna do is to show you, hopefully this works, because we did pray to them demo codes a bit earlier. So I'm gonna say, this is my age, and I'm gonna generate the Jyoti QR code credentials. So this QR code contains the information that we mentioned earlier. So I'm gonna share that with Lucidity. I'm gonna send that as a Slack message because his application doesn't have the ability to scan the QR code yet, but I'll do that through Slack. And then I think I can switch over to your screen so you can show what's happening on the verification side of things.
Right, I shall now share my screen.
Yeah.
Okay. Right, so I've received the, I'm Phil from Lucidity, by the way, I'm the CTO. So as Paco said, we built this system. There's been virtually no conversation between us. We've just agreed the process that needs to happen. More discussion about the QR code than anything. And how to make the QR code smaller. They're the kind of issues that you get in practice. I'm just going to download this QR code. Okay, so I've got the QR code now on my machine. What I'll do is I'm going to open that in here. On that file. Okay, so the reader that I've got in this this little test harness has obviously used the PKI and decoded it, and that's the payload that was contained within the QR code. And it's really as simple as that. We can do it the reverse way around. So if I issue a QR code, I'll just issue one. Let's just say 19 years old. I'll issue a QR code. And if you want to take control.
Yep. Yes. So I'm gonna now use the UOT scanner implementation. We do have a camera capture process. So what we're gonna do is just do a bit of QR code scanning with laptops, which I think it's never been attempted before.
I know this is the height of technology going here.
There you go.
Yeah.
So again, we managed to verify using the public key of Lucidity that this credential is valid. So it's over 18. There's an anonymous credential identifier, so nobody knows that this is Phil. The assurance level is set to pass H. And because we're so privacy preserving, there was a timeout of only showing this for 10 seconds, but hopefully you got the rest of the credential. So yeah, with this, we've done the interoperability test in practice both ways. But again, this is something that any member can basically join the PKI and issue codes and verify codes at a global scale. So I think that's the end of the presentation.
That's where we can go, take questions if anyone.
Just one. So obviously you showed, let's say, a full verification process, but you're sort of planning to, or tested it also for just age estimation. So
Right.
It doesn't matter what kind of level of age assurance we'll do?
Yeah, so each identity provider, they will have the ways to verify age. So for example, in this one, it's been kind of self-certified. I put the age in there, but IDPs, identity providers, will have the method to verify with documents like passports, travel licenses. Other organizations may choose to use AI and age estimation to be able to generate a credential just with a face, so no document required. and this system will basically work with that as well. So
What's the maximum size of payload? Or, yeah.
so we did with
Paco, I don't know if you can hear me, but the sound isn't working for those of us who are online at the moment.
and is the company if you want. It was
Perhaps there's a microphone problem. It was fine until you went to the audience.